Guys, so when I first bought this mill, this stuff was just like locked in place, I guess, from years of oil buildup or grease or whatever it was. But you know, it was a real pain in the butt to get these, to get all this stuff apart. But today, I've cleaned this up since. It was fairly easy to get these handles off, and the keyways are all in good shape because I took them all out. I scraped everything out, cleaned everything of the oil and the old grease residue. So what we're doing now is we're just going to pull these end caps off so we can get this lead screw out, and then we could go ahead and put the new lead screw in the mill. And typically there's not a lot to it. You have I can go over it with you real fast. You have this bushing which slides off. I'm probably gonna have to pull this keyway out to get the bushing off. And then you have this is your micrometer which slides on. Then you have, this is a locking, so you can obviously reset this to 0 or wherever you need to reset it when you're making a cut. And then you have your handle, and you have the little nut that stays on there. So now we have four hex keys here. These are 5/16 headed hex keys, and then of course there actually are two drive, I don't know if they call them drive pins, drift pins, but they just do some alignment. And of course this is just not long enough to get around that, so we're going to do this manually. I'm going to go ahead and move the camera and get this off. Okay, now all that did was once I got the 4 hex keys or hex screws out, it just a couple taps with the brass hammer to get this end cap off. And there you go, there we have it. So rather than take the table off, I'm just going to go ahead and put the handle back on, and I'm going to unscrew the lead screw just with this handle. And you can see how clean everything is, because I did clean this way before I put it back together. And I'm just kind of supporting it in my hand because we are running still through the brass nuts and we don't want to mess them up. Okay, we got to the end of our threads. We're just going to slide this out by hand carefully. Okay, there we go. Now I'm going to get some rags and clean my hands off. We'll get this new lead screw so we can kind of compare the two, and I'll show you those in a minute. Okay guys, you can kind of see here the difference between the power feed lead screw and the non-power feed lead screw. This left side of the lead screw is just about exactly the same, or it is exactly the same. All the step downs are identical, and of course the 2 keyway slots are identical. Now as we move over, I'm just bring you over here. You might have a little shakiness going on, but here is the big difference between the two. Make sure we're in focus here. So you can see this one's obviously a bit longer. This main shaft here seems longer, or is. There's a hole for a pin that goes through. That's not there. And I guess this is where the other bearing cap would go for your single bearing on the right side of the table. So looking at the 2 screws, it looks like the lead screw from the power feed unit is in quite a bit better condition. I've quickly taken just a caliper and kind of measured the thickness of the Acme thread, and it's quite a bit more consistent. Whereas you can see it's the regular lead screw, the ends are thicker than the middle, probably by like 7/1000ths actually. Just a rough measurement. I'm not trying to be perfect here. So this has considerable wear on it, but again, just for standard milling and with my DRO and such, I should be able to adjust some of the slop out with the nut, and it's this is just going to be fine temporarily until I can procure a new lead screw for this machine. And I've also put just a piece of wood up here to kind of protect the table a little bit, because I didn't want to ding the table or the lead screws up. Okay, so let me reposition the camera, and we're going to set about to install this replacement or non-power feed lead screw. Okay, we re-angled the camera, got some lights on the subject, and took the liberty of bringing it down here. Here you can see our nut, and you could actually see the two screws. There's a small flathead screw, that's a locking screw, and then there's a larger screw, flathead as well, that is the adjustment. So this way you can go ahead and adjust the brass nuts to take up some, for some of the wear in the actual screw, or for also taking up some wear in the nut itself, because the nut is programmed to wear easier, being as it's brass, than the actual screw. And is it brass or is it bronze? I'm not 100% sure, but you get the idea. So now that we've got everything kind of cleaned up a little bit, we're going to go ahead and install the new screw. So I've put a couple pumps on the Bridgeport lubrication system, and I've slathered a little oil, light oil, on the screw itself. So we're going to try to get this guy in here without too much clunking around. At least I get a part way in, I could go ahead and get the end cap on with the bearing. And I'm just going to go a little more oil, put a little more oil on it. I don't want to make too much of a mess. The Bridgeport oiler actually lubricates this as well, so I'm just putting a little oil on there. It will in fact work its way in, just like it always does. And the best part is, it's not a big deal to get this out, to put the new screw in once I do get it. And I'm going to go ahead and put the handle on so I can get it on there a bit quicker. Okay, this is great. So now at this point, we can get our end cap on, get that kind of into position. I think I have to bring it in a little bit further, but it's a tight fit. I should have screwed that in a little bit more first. Although I did clean it, I didn't check it for burrs. But on the other hand, I can actually slide the table from the right towards me, from the right to the left, and actually bring the table to the. So we just gotta get those pins aligned. Okay, well, maybe put two screws in there just to hold it from falling. There you go. Okay. Maybe we'll get the other 2 screws in. I will get these 4 screws in. I'll be right back. Alright guys, so we have our end cap installed. It's seated in the bearings properly. We have our graduated dial installed with the clamping or the insert in there to clamp it. We have the locking screw. We have the handle on. Now we're just going to go ahead and thread this handle nut back on. And I actually might have a little problem with this because it looks like the threads are a little boogered. Somebody probably clunked this on the concrete. So I may have to find a tap to clean this up a little bit if I can't get this started, which it doesn't look like I can. I mean, maybe. You don't want to cross thread it, obviously, and that's what's happening. Alright, let me find a proper tap and we'll just clean the threads up a bit. Okay guys, so we're at the other end of the Bridgeport now, and we need to install this part. Surprised there's no bearing in there, but I don't know. We will follow the instructions and see what happens. I'm actually surprised there's no pins in here either. So I picked 2 of these up on eBay and they were extremely reasonable. I'm talking like $108 each shipped. So I thought for that amount of money I could at least try them and see if it doesn't work out. Well, it's not really a huge loss. I could send them back probably if I do this in a reasonable amount of time. I'm not going to tighten these up fully. I'm just going to get them at least to the fact where they're not snugged up, but at least fairly installed, just to see what happens. When I took this mill apart to bring it here, I brought it here and chased all the threads. So it's fairly easy to get the bolts back in. Okay, let me go ahead and move on to the next step. Okay, Okay, so I've decided to move all that that rack of collets and all that stuff out of the way so I could get some room in here to work. And now, as you can see, I just went ahead and hung this power feed on the shaft. And I'm going to go ahead and put the next two Allen key bolts in. It's sitting on two spring pins that are on this black end cap for now. Okay guys, so now we physically have the power feed attached to the mill. And to recap, the steps were obviously remove everything off the side, put the end cap on, the supplied end cap. Go ahead and put the actual motor, hang the motor on. There's a bushing that goes around the lead screw and inside this actual motor housing. And then they give you two different types of shims. They give you thick shims and thin shims. They tell you to start with two shims, two thin shims, to see how the motor aligns with the bevel gear with the actual unit. So we're going to go ahead and slip the bevel gear unit on. And that fits in there nicely. Then they give you a wiggly washer. That's next. And then your existing dial, you slide that on. And it looks like a fairly decent gap so far. This part, I guess we have no choice, but our metal tightening ring for this does not fit. It's not the same thread. So eventually, I may go ahead and try to rethread this at some point when I get time, but they give you a plastic one. Kind of cheesy, but okay. So you can leave that loose or tighten it up. That's just for reading your dials. At that point, they tell you to go ahead and put a couple more washers, two thick washers here. Now, I'm not going to do that because the dial, well, I don't know. Maybe I'll put one thin one in. I don't have a lot of room here on this thread between the handle and the thread. So go ahead and we'll put that on anyway. You kind of see what I mean. I don't have a lot left over here. So I could get, you know, a quarter turn on it. And I'm just going to go ahead and very snug that up just ever so slightly. At this point, this is real close to the wall for me, and I'm a lefty, so I don't really use this hand wheel too much anyway. So I'll probably be using the left hand wheel much more than the right. And, you know, just, I don't need to do it that much. But she's plugged in. Let's turn her on and see what happens. Okay, with a red light, I guess that means we're all good shape. So let's toggle it. It sounds nice and quiet. We have adjustment screw, and we also have a fast traverse button. I mean, it sounds okay. Doesn't seem like there's anything seems like the gears are mashing up nicely. Alright guys, well, that was pretty easy and straightforward. I think we're in good shape. One thing I must tell you though, I don't know if you can see it here. Let me get you zoomed in and move this camera a little bit. Okay guys, here's something I did want to mention. It's all about leveling your mill. A lot of people don't believe that leveling your mill is necessary, and that possibly could be true. But what I do notice, if you have an automatic oiling system on your machine, and probably even if you don't, I mean, you have to oil it all the time, and that's a necessity of being a machine that moves. Anyway, what I found is if you have an automatic oiler and your machine is not level, the oil always goes to the front or to the back or to the left or to the right when you're doing your weighs. So level up your machine. That way, when you pump the oiler, the oil will distribute, via gravity to where it needs to go. If the machine is heavily tilted to the left, the right side's not going to get oiled, especially underneath the table. So what I did was I just got some studs from McMaster. And I tapped and threaded the holes in the base of the mill, 3/4 by 10, and then I locked the two nuts against each other so I could go ahead and use that to actually lift the mill up. Now, I think down the road I'll probably have like a different solution. I might put, possibly, I don't know, some kind of bars that go across. And go ahead and put outriggers on it, or I don't know, or maybe I'll just leave it the way it is and shim it. But I do get, I'm very fussy about my machines. I do get a little moisture in this corner of the building when we get really heavy rains. So I like to keep the machine off the floor anyway, so it's not touching, because there does come a little water in here. And I do have a dehumidifier that runs to keep the humidity down. But that's just something, the building is old and I can't do anything to the outside of the structure because there's kind of another wall behind this that is the bathroom. So that's what I got to do. So like I said, that could be a little tip just to keep the machine level. That way it oils properly. Okay guys, well this concludes our video on installing this power feed machine on our Bridgeport mill. I got a couple observations. I found out later in my installation that it was kind of making a funny noise when I was turning the handles by hand, and it seems like there's a roller bearing in here that was hitting, so I had to just adjust that a little bit. I just tapped it with a socket and it worked fine. One thing I later determined as well is that I had trouble sliding the brass gear onto the shaft of the lead screw for the milling machine. And what I later determined, and I got excited that this came out great, and I decided to install this on my 56, is that the woodruff key is quite a bit thicker. Especially on the 56, it won't even go on, and that will be a subject of an upcoming video where I'm going to have to broach this bronze or brass gear out to fit my 56, because I started to assemble that, and I could show you that in a second. But overall, I'm pleased with it. It works fine. It's got the high speed traverse both ways. It's great. One of my cons, I don't like this. I think this is really flimsy, and I don't like the fact that these stops, they're too far away from the table and they're not parallel with the table. They angle out. So what I'm going to do is I'm going to go ahead and make a couple stops. I'll probably do a video on making replacement L brackets for this. So when you slide it, it just seems like it's kind of hitting on the edge and it's kind of cocked, and I'm not really happy about that. I'm going to show you real fast. I'm going to move us over to the 56, and I'll show you my progress on that one. Okay, here's where we're at with the 56. I have the unit installed. It's on fine. I cannot get this onto past these woodruff keys. That slot is not wide enough. Let me bring you over to the bench and show you. Okay, guys. So here we are at the bench, and here's our new gear. And I can't measure this right this very second. I'm going to do another video. I cannot, you know, we need to broach this. Widen this slot ever so slightly because it doesn't fit. I mean, I know it should be nice and tight because we don't want any slop in there. And then that will induce wear, especially in this soft metal. But we're going to go ahead and we're going to find a way to broach this out. Whether we do it on the mill or we have some other technique to do it, that's going to be in one of my upcoming videos because obviously I want to put my other mill back together. So those are my pros and cons. And of course I don't like the fact that I can't use my metal, this piece, my metal adjustment, my tightening for the dial. I can't use that. I have a plastic one. The threads are different. So that was a con for me. But again, for $100 from Amazon, I definitely recommend it, especially if you have like a little bit of time to mess around with it and get it to work. I would have loved to have bought servo feeds, but for the money, it's unattainable. You know, more money better spent on my CNC conversions. You know, obviously I care about my manual machines as well, but if these last a little bit, that's fine. Even if I have to put them back to the manual hand feeds, you know, no money, no love lost. So there you go. Again, thanks very much for watching. I hope this helped you guys out in your installation if you want to install it. I was a little intimidated at first, but it turned out to be a super easy project. 8 bolts, couple washers, no big deal. So have a great day. Hope you guys are doing something in your shop, and I'll see you again soon.